Welcome to Scripting for Packaged CCE. In this session, you will be introduced to the fundamental concepts behind Packaged CCE scripting and be shown how to create a simple script. Scripting for Packaged CCE follows the same model as scripting for UCCE. Packaged CCE requires the use of CVP as an IVR engine. Therefore, this training session will discuss elements of scripting for both CVP and ICM. In order to understand how to script in Packaged CCE, you need a solid understanding of how the call flow affects the requirements for scripting. In Packaged CCE, the call flows are fairly straightforward because there is only one agent peripheral. Additionally, Packaged CCE requires CVP for caller treatment, whether it is for the prompt and collect or queuing announcements. All inbound calls for Packaged CCE deployment will enter through a voice gateway. The voice gateway will match the inbound DNS to a dial pair that directs call logic to CVP. CVP then, based on CVP configuration, directs call logic to the Packaged CCE call server. The Packaged CCE call server then accepts the inbound call logic as a route request. It is at this point that the Packaged CCE script is invoked on the call server. You should make note of these important distinctions. For most deployments, call logic will always enter the system via the voice gateway and be presented to Packaged CCE from the CVP. Therefore, the inbound routing client is always CVP. The Packaged CCE script is the primary factor that determines the caller's experience. In other words, the Packaged CCE script controls everything that occurs for a call until it reaches an agent. So the next question is, what can the Packaged CCE script do with a call? Packaged CCE can direct the call to be sent directly to an agent. It does this by sending a label to the CVP, which then directs the voice gateway to move the call onto an agent via CUCM. Or, if needed, Packaged CCE can direct CVP to connect the call to the voice browser in the gateway to provide caller treatment while the caller is in the queue. Or, if collection and decision type activities need to be performed, such as prompt and collect, or some type of database access is necessary, Packaged CCE can direct CVP to connect the call to the voice browser to conduct these activities. These activities can be performed by using two basic types of control. The first is invoking micro applications from the Packaged CCE script. The second is invoking voice XML scripts that reside on the CVP vXML server. Before you create a Packaged CCE routing script, there are basic requirements that must be met. You must have the peripheral defined, a skill group, an agent that is a member of that skill group, and a dialed number that will be scheduled to use the Packaged CCE script. A Packaged CCE routing script can look as simple as this one, although to be fair, you would never have a script this simple since it does not provide any type of queuing or other activities. It simply allows a target to be chosen if there is an agent available. For this or any other script to run, you must associate the incoming dialed number to a call type and then associate the call type to the script. This is done by using the Call Type Manager accessed from the script editor under Script Call Type Manager. Consider the script being displayed now. It can only be used to select and deliver a call to an agent. All else releases the call. The skill group node is used to define the agents that are available to be chosen. But to be more accurate, the skill group node is a list of targets, or in this case, skill groups that can be chosen. The select node is used to define the criteria for choosing a target in the skill group node list. LAA, as seen in the script, refers to the longest available agent statistic that can be used as target selection criteria. The LAA statistic is a common skill group reporting attribute that is commonly used for decision-making criteria. Also note that there are other Packaged CCE scripting nodes that are more commonly used today. The separate select and skill group nodes are used here to aid in demonstrating a basic concept of agent selection. The concept being that in every case, you must have something that defines the agents available to be chosen, and something that defines the criteria for choosing an available agent. For any call center that needs to queue a call or provide additional prompt and collect activities, you must use some IVR platform. Packaged CCE uses Cisco Unified CVP as a platform for providing caller treatment while calls are in the queue and for any additional prompt and collect activities. There are two methods of invoking Cisco Unified CVP for IVR activities. The first is to use microapplications directly from Packaged CCE call server. The other is to use voice XML scripts from the vXML server. There are a number of requirements for Cisco Unified CVP, which include a peripheral definition associated with the network VRU definition. The network VRU definition must be set as the default network VRU. ECC variables must be defined and enabled. The Packaged CCE call server uses ECC variables to pass instructions to the Cisco Unified CVP call server. And of course, Cisco Unified CVP and its associated components must be installed and fully operational. In addition, a voice gateway with voice browser, basic call handling scripts, and media files will be needed. The scripts and media files originate from the Cisco Unified CVP call server. Microapplications are single-action Cisco Unified CVP voice XML applications that are natively understood by Cisco Unified CVP call server. They include the following applications: the play media, which plays a file to a caller; the play data, which plays audio to a caller that was derived from information such as the time or date; the get digits, which plays a prompt and receives digits from a caller; the menu, which plays a prompt and accepts a choice from the caller; the get speech, which collects ASR or DTMF input after prompting the caller. Each microapplication must be initiated from Packaged CCE Script. Microapplications are initiated from the Packaged CCE Script and are declared as network VRU scripts. This is a view of a Packaged CCE Script that allows for agent selection and queuing. Again, notice the select and skill group nodes. They will allow agent selection if one is available. If an agent is unavailable, the select node will fail to the queue to skill group node. Once the call is queued, you must provide some kind of caller treatment. In this case, some simple announcements. Next, we'll take a closer look at these nodes. The first and most crucial thing you must know about communications between Packaged CCE and CVP is that when Packaged CCE sends commands to CVP for caller interaction, Packaged CCE uses ECC variables to pass that knowledge to CVP. This always happens whether you are using micro apps or vXML scripts. CVP will then take data from these ECC variables to build an HTTP post that is delivered to the voice browser in the voice gateway. The voice browser then uses the HTTP post to access the voice XML script or media files. In this example, the script is using micro apps to play simple WAV files. The set nodes here are providing CVP with information as to where the media files are located. The first set node indicates the server where the media is located, and the second set node indicates the locale or language folder. By default, within each locale folder, there are two subfolders, App and Sys. The App folder is used for user-defined or custom WAV files. The Sys folder is used for system-provided WAV files. By default, the CVP system will look to the App folder when none is specified. Therefore, the set node is not necessary, but is being shown for clarity. The Run External Script nodes are being used to specify which WAV files are to be played. Call Studio is installed as a component of Cisco Unified CVP and is the scripting program used to create voice XML scripts. It uses a graphical drag-and-drop interface that uses script nodes called elements. It allows you to create scripts from Call Studio projects. You can create new or import projects into Call Studio. The result of Call Studio project is exported and is finally seen and executed as a set of voice XML directories and files. These directories with voice XML files are placed on the voice XML server for use by the Cisco Unified CVP system. When you start a new project, there are several types to choose from. You want to start a new Call Studio project. Provide a name and a directory location for the project. Click Finish. The project appears in the Navigator window, and the beginning of the script appears in the Design window. Default settings for the project can be found by navigating to Projects, Properties. This figure shows the default audio settings that can be changed based on your deployment. All Cisco Unified CVP scripts must start with a CVP sub-dialog start element and end with a CVP sub-dialog return element. It is analogous to accepting control of a call and returning control of a call to Packaged CCE. When the element is highlighted, settings for that element are available to you. The sub-dialog start allows accepting information from the Packaged CCE. The sub-dialog return allows the return of the data to Packaged CCE. To connect elements, right-click Element, choose the output branch to connect. Drag and drop the output branch onto the next element. Next, add an audio element to play the welcome prompt. The element can be easily renamed. Note that this is not using the default audio path, but using an explicit URI. A two-option menu has been added to prompt the caller to make a choice between sales and service. Note the settings and values. Option 1 is DTMF digit 1. That sets the value to a string value of sales. Option 2 is, of course, for service. The audio setting specifies the prompt to be played. If the caller chooses 1, sales, or does not enter valid input, the script will end and send back the value for sales in the caller input field. For any Cisco Unified CVP script, the caller input must be set with some value whether you intend to use it or not. Highlight the field name and click the ellipse to open the substitution builder. Since this is element data you want, using the Element tab, use the pull-down menu to choose the menu element. Then choose the field you want. In this case, it is the value field. Notice the other tabs available to you. They allow access to data from different sources. The two tabs that are associated with script data are element data and session data. Element data is that data that is collected by an individual element. When data is assigned to an element, the element is said to own that data, meaning that while other elements have access to that data, only the owning element can set the data. Session data is more global in nature. It can be assigned from any element, but can also be changed by any element. Another menu is added. This is a 3-option menu to determine which service group the caller wants. Again, the value field is populated with a string value indicating the type of service desired. Another 2-option menu prompts the caller as to whether this is a new or existing trouble ticket. If the caller indicates this call is for a new trouble ticket, or if the caller fails to enter a value, the script will populate caller input with the service name chosen and populate external VMXL 0 with the new trouble response. The script will then end. As an additional note, caller input is an ECC variable in Packaged CCE as well as external VXML. External VXML has 4 fields because it is defined as a 4-element array. Next, the script will use a capture type of element called digits to collect the existing ticket number from the caller. It assumes a 7-digit ticket number. The digits collected by this element are placed into a field called value. This is not obvious, nor is it even viewable from this perspective. This is accomplished by the element by default and is only viewable in the substitution builder. The need to store and collect digits in another element or session data field is not required for this script because, as mentioned before, by default, the digits collected are stored in an element field called value. This is simply a demonstration showing how you can add and use your own variables. On the Data tab, click one of the radio buttons for element or session. Enter a variable name, and then enter a value for the variable. In this example, the value field of this element is being used to populate the session variable. Choose to create and populate this variable after the collection has occurred. Click Add to have it implemented and displayed in the session data area. This element now has 2 variables of the same value that can be used elsewhere. All the output branches of the data collection element can be sent to the existing subdialog return element. The subdialog element is still populated correctly, except the inclusion of the ticket number in the external VXML1. This is an example of a completed script. To validate the project, first save the project, and then right-click the project name and choose Validate. To deploy the project, right-click the project name and choose Deploy. Choose the project to deploy, browse to and designate a directory and file name. There are multiple ways to deploy a project. Deploying to a zip file is the easiest and most automatic method of deployment and activation of a project. Click Finish to create the zip file. Access Cisco Unified CVP Ops Console from the machine hosting Call Studio. Navigate to Bulk Administration, File Transfer, vXML Applications. When the transfer completes, the project will be available to the Cisco Unified CVP. Now the Packaged CCE script can get a little more complicated. This demonstration will show how to incorporate the new Cisco Unified CVP project into the Packaged CCE script. The current Packaged CCE script will be modified to provide for prompting and collecting of the caller before agent selection. You will notice there are several set variable nodes here. As stated before, Packaged CCE uses ECC variables to pass control information to CVP. CVP will accept these variables and use them to build an HTTP post that points to the VXML application of the VXML server. If you watch closely over the next few slides, you will see that the resulting HTTP post will look like this. The first set node is used to set the location of the media server for the project. By default, the system uses port 7000 CVP. The second set node is used to set the media library, or a secondary path to the media files. The ECC variable user.microapp.toextvmxl is an array variable used to pass information to CVP. Use the third set node to pass the application name and the media ID of the call to CVP. Values are passed as named value pairs. The example being shown is the concatenation of two named value pairs that will be used as part of the HTTP post. The next set variable node sets the use VXML params ECCE variable to n. This parameter specifies the manner in which you pass information to the external voice XML. N, for no, tells CVP to build the name value pairs in user.microapp.toextvxml to the URL of the external voice XML. The send to VRU script node is used to send a label instructing CVP to connect the call to the voice browser in the voice gateway. The run external script node is being used to instruct CVP to run the designated VXML script on the VXML server. To clear up some confusion, consider these points. This is a micro app called getSpeech, but in this case it is not being used for that purpose. This script name, GSServerV, is using a special format that CVP understands to call an external VXML script. The location and application name of the external VXML script are defined in the set variable nodes that have just been discussed. When this script node executes, the caller will navigate to VXML application package CCE _call _studio _demo. When the caller completes the VXML application, controller logic will exit the succeed terminal of this node. Now that the caller has returned from the CVP script, you need to populate the peripheral variable 1 so that the ticket is passed to an agent as enterprise data. That, of course, assumes that this caller had an existing ticket. Therefore, you need to test the return information to see if this call is about an existing ticket. Use the if node to do this. The formula shown here tests array index 0 of the from ext vxml ECC variable, which would be populated if this was a call about an existing trouble ticket. Remember that this was set in the CVP subdialog return element in the package CCE _call _studio _demo application. Now that the script has determined that this was an existing trouble ticket, set the ticket number to peripheral variable 1 so that it can be passed to the agent. The value shown here is pulling the ticket number from array index 1 from the from ext vxml ECCE variable. Again, this was populated in the package CCE underscore call underscore studio underscore demo application. The package CCE script now looks like this. The beginning of the script sets the information that points to the package CCE underscore call underscore studio underscore demo. If there is a ticket number, set the peripheral variable to 1. Next is to get the caller to the correct skill group. The select and skill group nodes have been removed because they really aren't needed. The queue to skill group node will be sufficient. Open the queue to skill group properties and set each of the skill group targets. Use the consider if statement to test for the correct caller input. The script is now complete. Here is what the completed package CCE script looks like. This concludes the scripting for package CCE session.